In this video, we will see how we can find the prime factors of a number easily using factor trees, and from there determine the greatest common factor and least common multiple of any two or more numbers. To find the prime factor tree of 24, first we need to find two numbers whose product is 24. Let's say 4 and 6. 4 and 6 are factors of 24. Now we do the exact same thing for 4 and 6, from which we get 2 times 2 and 2 times 3 respectively. At this point we cannot break all these 2's or 3's down to smaller numbers the way we have been doing so far, which means that our factor tree is now complete. These numbers are also known as prime numbers. Therefore, we can say that 24 has been factored successfully into a product of prime numbers. Similarly, we create the prime factor tree of 36. Since 4 times 9 equals 36, the first two nodes will be occupied by these two numbers. Now, 4 and 9 can be factored into 2 times 2 and 3 times 3 respectively, so the numbers at the bottom of our factor tree are all prime. Now, from this tree we can get the prime factorization of 36, so we can safely say that 36 equals 2 times 2 times 3 times 3, which is absolutely correct. It's advisable to write the prime factors in ascending order, as it will help us find the greatest common factor and the least common multiple more easily, especially when bigger numbers are involved. By combining these two expressions we can find the greatest common factor of 24 and 36. This is where we scan both expressions in columns looking for what else? Common factors, which must then be multiplied. This column has different numbers, so will be ignored. Hence, the greatest common factor of 24 and 36 is 12. You can think of finding the greatest common factor as using columns and matching only the like factors. Now, to find the least common multiple of 24 and 36, we work in columns again, looking for common factors as we did previously. But first, let's stretch the prime factorization of 36 and leave a space where there is no match. Now, all the numbers will be taken into account, even the ones without a match. All we need to do is to use just one factor from every single column and find their product. The product of all these colorful numbers is our least common multiple, which in our case turns out to be 72. With this arrangement we can see the numbers that the least common multiple and the greatest common factor have in common, and of course, the ones by which they differ.